All right. So which process does not involve the use of catalyst? Now, we know that most redox reactions, we don't really need to use catalyst unless the activation energy is too high or something. So extraction of iron from hematite, that is a pretty straightforward redox reaction. We use carbon as a reducing agent. So this does not need a catalyst. So this is my answer, but let's still consider the others. Sulfur trioxide, I will need B2O5. It's a reversible reaction. Production of ammonia, again, reversible reaction. I want a catalyst to push, to speed the things up. It will not increase the speed of forward reaction only. It will increase both the sides. The redox reaction that remove combustion pollutants from car exhaust, we use 3 different catalysts for that. So again, this is not relevant. Gaseous compound X is an oxidizing agent. So the answer to previous one was A. Gaseous compound X is an oxidizing agent. X is bubbled through separate solutions and of aqueous potassium iodide and aqueous potassium manganate. Now, why are these 2 components important? Because these are the redox agents in our syllabus. So we know that potassium iodide is a reducing agent and potassium manganate is an oxidizing agent. So if something reacts with a reducing agent, it's an oxidizing agent. If something reacts with an oxidizing agent, it's reducing agent. Now let's see. We have an oxidizing agent. So it must react with iodide, but not with manganate. Okay. So let's see. With iodide goes colorless to brown. Yes, that is C or D. And with the other, no change. So that is C. So the answer that I'm looking for is C. Does that make sense? If you have any question, feel free to unmute yourself at any time and ask. Which metal oxide will be reduced by heating with iron? Acha, ab yahan par we have to look at the reactivity series. The reduction by iron depends on okay, which metal oxide will be reduced by heating with iron? So in the reactivity series, so we start with whatever the things are. We just have to know that because we're using iron, things must be less reactive than that. So what is less reactive than iron? That is lead. That's the only one that's less reactive than iron. Now, how would you know? Even if you don't remember lead in the reactivity series, you still know that zinc, magnesium, and calcium are more reactive than iron. So B is the option through elimination as well. So yes, you're right, it is B. Which pair of substances can be used to prepare a sample of lead chloride when added to water and mixed? Achha. Again, the only thing you need to remember is lead chloride soluble or not? And chlorides का हमें पता है कि हमारे पास silver, mercury, lead, they are insoluble. Okay, so because of that, we can take this one. Achha, ab aapke syllabus mein this year lead is not going to be on the question, but it could very well be something else that is insoluble. They could have given us silver chloride. ठीक है, तो हमें पता होना चाहिए कि we are making an insoluble thing, और जब आप insoluble thing बनाते हो, so then you're looking for 2 soluble compounds. So let's see. Lead and sodium chloride not likely to react. Lead is not going to do a redox reaction with sodium chloride. Lead nitrate and sodium chloride. Lead chloride is made, sodium nitrate is made. Yeah, looks like a possibility. Next one, lead 2 carbonate. This is a solid in itself. It's an insoluble thing on its own. So why would it react? It wouldn't. Okay. Next, lead and hydrochloric acid. Again, for this one, lead chloride, even if it's made, it's not going to be as affected. And so because of that, we're going to see. We have a new student, so hold on, just let me add them to the class. Okay, so yeah, so this is going to be B. 2 soluble things coming together to produce an insoluble thing. Okay, and of course, another sodium nitrate, which is soluble, but it's irrelevant. Okay, moving on. The pH of an aqueous solution of hydrochloric acid is 2. What will be the pH after addition of 10 grams of sodium chloride? So when does the pH change? Number one, if the thing reacts, that is when the thing changes its pH. The second thing is if you dilute it too much, but that calculation is not in O-level or IGCSE syllabus. So we'll restrict ourselves to knowing that if it reacts to produce something with a different pH, only then the pH will change. Otherwise, it will not change its pH. Okay? So hydrochloric acid is HCl. Is it likely to react with NaCl? Both are chlorides. Nope. They're going to just form an equilibrium. Both are soluble. They're going to stay as it is. So pH is not going to change because no new thing is being made. And that is why the answer is B. Now, interestingly, you might notice that we have had 3 Bs in a row. Lekin, I told you in the beginning of the session, Friday wali class mein, that when you're solving it, transfer your answers right away while you're doing a paper. That means if you were transferring them, otherwise it's likely that you galat kar doge, you confused ho jaoge, or you will be like, why do I have 3 Bs in a row? But this way, you will not have that problem. Okay. Which statement about the elements in the periodic table is correct? Hello. Yes, Iman. What's your question?
Sir, could you explain question number 25 again?
Yeah, sure. So in question number 25, what they're doing is they're adding sodium chloride to a solution of HCl and are asking us whether it will change the pH. For that, we have to remember that the pH changes if a new product is made. If a new product is not made, then pH will not change. The second case, again, I'm just telling you that will not apply to O-levels or IGCSE. The second thing when pH changes is if you dilute the thing, if you add too much water. But that is not relevant in O-levels or IGCSE. So for our cases, when a new thing is made, that's when the pH changes, otherwise it doesn't. Yeah, Tanisha, do you have a question? Sorry, it's Viditi. What's your, how do you?
It's Viditi. I changed, I joined from a different account. I joined late, so can I have like the pre-recording if possible?
We did not, I do not intend on recording these sessions, but I do have the recording for Saturday. I'll share that with you. All right.
Okay, thank you.
All right. Okay. Question number 26. Which statement about the elements in the periodic table is correct? All right. So all the elements in the same group have the same reactivity. We know that is not right. And if you feel like no, it is, then just remember any group that you know of. So group 1, we know reactivity increases downwards. Remember, sodium and potassium, they have such a stark difference in the way they react with water. Similarly, in group 7, we know there is the color changes that are associated with displacement. So within the same group, displacement is possible. So that means they have different reactivity. Otherwise, displacement wouldn't occur. All the elements with 4 electrons are metals. Group 4 is right in the middle of metals and non-metals, right? So there are some metals like at the bottom and some non-metals like carbon at the top. So yeah, this one's wrong. An element in group 2 would form an ion with 2 minus. If you're in a haste, you might be tempted to take this option, but it is 2 minus and this is group 2. It must be 2 plus because they can lose those 2 electrons. All right. Last option, elements in the same period have the same number of shells of electrons. So period means same number of shells, right? So this is D. Now, you might be thinking that if we have already eliminated the first 3, why do we have to still read the last option? Why not just say that that is the answer? Because sometimes we misinterpret the option. So what if I read D and I figured out, wait a minute, that's also wrong. So then I would know that one of the options in ABC is correct. So I will reread it. So do not make the mistake that just because you have eliminated the first 3, you don't need to read the fourth one. It is possible that you might need to reread the options. So always read the option that you're going with. Sabine's question is, in which kind of reaction could the pH change? So pH might change if HCl would react with something to produce a different thing. So for example, HCl can act as an acid and it can react with the base and then the pH would change. Or it could be that HCl reacts as salt and produces another salt. So I'll give you an example. What if HCl reacted with AgNO3? Now here, HCl is acting as salt because AgNO3 is not base. So Cl will react with Ag and H will react with nitrate, and HNO3 will be made with AgCl. HNO3 has a different pH than HCl, so pH will change. But in this case, when we had HCl and NaCl, pH wasn't going to change because they were not going to produce a new product. So as long as the reaction does not happen, pH will not change. Okay, remember, pH is a chemical thing, so only a chemical change can change it. Okay, iron is extracted from hematite in the blast furnace. Okay, which other raw material is added in this reaction? So iron is extracted from hematite. What are raw materials? This term has been misunderstood by students multiple times. So you have to remember that raw materials are things which are not formed during the reaction. Okay, so for example, carbon dioxide is formed during this reaction. So in this reaction, carbon dioxide is made, carbon monoxide is made, but they're both made during the reaction. They're not raw materials. Okay, so let's look at this one. Which is the raw material being used? We use limestone. Yes, we do, because we need calcium carbonate to react with the acidic impurities. That also has been asked by the examiner multiple times, that what is the role of calcium carbonate? It reacts with acidic impurities. Remember, we have SiO2, which reacts to produce slag. So slag is produced in the reaction. It's not a raw material. Limestone is. Cryolite and bauxite are both raw materials, but for aluminum's extraction, not for this one. By the way, another reaction in which they ask us about raw materials is the one where sulfuric acid is made. So let me write the equations of sulfuric acid and tell me what are the raw materials. So this is the first reaction, sulfur dioxide is made. Then that reacts with oxygen in a reversible reaction to produce sulfur trioxide. Then that sulfur trioxide reacts with water, produces oleum. Oh, sorry, this will produce H2SO4, but in a very exothermic process, so we use H2SO4. So H2S2O7, and then that will react with water. So tell me, what are the raw materials here? Go on, don't be shy. There's no shame in making mistakes here. Oxygen, water, sulfur. Very good, Sabine. Is H2SO4 a raw material? Because we can see that it is being produced here. Sorry, used here. Is this a raw material or not? Why not? Because it is being produced in the reaction. You see, it is being produced over here. And you can also, by the way, practically when this is being done, SO3 is added to water in limited quantity. We get concentrated sulfuric acid, then we start this oleum, this process of oleum. Okay, so I hope you understand that. Yes, Iman.
Yeah, in a very old question, I saw that the equation, wo jo sulfur oxygen wali equation hoti hai, I believe that is what they substituted with zinc sulfide and oxygen, and then they made zinc oxide and sulfur dioxide.
That's not an old question. That's actually the idea of using zinc blend to extract zinc as a metal. That is part of the IGCSE syllabus, and it will be part of O level from next year, not this year. An interesting thing about zinc is that zinc is the only metal that we extract as a gas. That's an interesting fact about zinc. You don't need to remember that. IGCSE people need to know that. Okay. The diagram shows a flow chart of the manufacturing of fertilizer. So what are we doing here? Fertilizers are sulfates and nitrates, most likely. Okay, so what's happening here? We get fractional distillation of air, that gives us gas W. That could be oxygen, nitrogen, argon, 3 gases that primarily we get from the air. So that means A is not the option. Okay, so we eliminate that. Then next is gas X comes from cracking of hydrocarbon. There's only one gas that we get from cracking of hydrocarbon that we can react with oxygen and nitrogen. In fact, that statement might not be wrong, might not be correct, because we can get different gases, different hydrocarbons that will react with oxygen if you burn them. We are not doing that here. So we can get hydrogen. But if you were taking oxygen from the air, you could burn many gases coming from cracking, like methane or ethane or something like that. Viditi, you should do papers from 2017 onwards. In fact, everybody should do papers from 2017 onwards. And if you feel like you don't have time for that, then I'm going to give you papers every day, 2 papers every day. So just solve those and you'll be fine. Okay, so it's going to be nitrogen and hydrogen. That is one pair that works for us, because SO2 you cannot get from cracking. So it is going to be D. I don't even need to look at the other options. But just for the sake of it, pressure Y, again, we'll need high pressure. And product Z, what is the product of nitrogen react with hydrogen? Ammonia. So there you go. By the way, can you think of something that we can add to ammonia to make fertilizers?
Calcium carbonate.
I'm sorry?
Calcium carbonate.
I'm sorry, can you type that in? Because आपकी आवाज समझ नहीं आ रही है. We could actually use any acid that will react with it, because then you can make sulfate. H2SO4 is a good option. We could use HNO3. That will make ammonium nitrate, which is a really good fertilizer. We could even react it with so we could react it with some carbonyls, and that will also produce fertilizer, but that's in A levels, not in O levels. Okay, the table gives the melting point, density, electrical conductivity of 4 elements. Which element is copper? So before you look at the options, know that the melting point of copper is high because it's transition metal. Its density is high, again, transition metal. Conductivity is high, transition metal. So we're looking for 3 options that are all high. It cannot be this one because it's poor conductivity. And in the other ones, we're looking for high density. That could be this one or this one. And then melting point is high, D. So D is the answer, right? So from 27 onwards, we have had 1 C and 2 Ds. Again, don't worry if you have multiple same letters as the answer. It's perfectly fine. Which gases are all present at the positive electrode during the manufacture of aluminum? Wait a minute, what's happening at the positive electrode? So at the positive electrode, we have, so aluminum oxide is first split into aluminum ions and oxide ions, right? Then these oxides are going to go to the positive electrode. It's not the aluminum. So they're going to make, oxygen is going to come in. It's going to burn the anode that you have, the graphite. Again, why is it burning it? Because the temperature is high. Graphite wouldn't react otherwise. There are 4 cases in which things start to become reactive or unreactive. I've uploaded a video of that on YouTube. I'll share the link with you in the group. So one of those cases is that graphite reacts at high temperature. So because this is happening at high temperature, oxygen will react. So oxygen is there. It will burn that, produce carbon dioxide. But if oxygen is limited, it will produce carbon monoxide. So C is the option. Yes, believe the answer is C. All right. The diagram shows the structure of brass. Why is brass harder than pure copper? Let me change this question a little bit. Why is alloy harder than a metal? And you know, this is a general statement now. Why is it harder? Because the size of the particles is different. So malleability is lower. These layers cannot slide over each other as easily. So let's see. The zinc atoms form strong covalent bonds. Nope. Zinc atoms prevent layers of copper atoms from sliding over each other easily. That is true because the layers cannot slide that easily. Alloy is less malleable. So this is B. There you go. All right. Which pollutant causes eutrophication? This is probably the last year they're going to ask us about eutrophication. It's probably going to be taken out of the syllabus next year. But still, let's see. Eutrophication occurs because of fertilizers, because they leach into the water bodies. There's an algal bloom, which means a lot of algae being spread and growing at a rapid pace. That uses up all the dissolved oxygen, kills the aquatic life in the process. So this is C. Okay, so B, then C. Moving on. How many moles of HCl are formed when 1 mole of methane reacts with a large excess of chlorine? Now, this is interesting because at any stage, only 1 mole of HCl is being made at any one stage, because only 1 hydrogen is being displaced. But if you keep on repeating the process, you will displace all the hydrogen, right? Eventually. So you are going to produce 4 HCl in the process. So yeah, this is D. By the way, the high achievers class that we do, we go through this process in long detail of how this occurs and why this occurs. But over here, just remember that every hydrogen is replaced 1 at a time. In fact, in all substitution reactions, atoms are displaced 1 at a time. Okay, that is an important thing to remember. Which statement about alcohols are correct? All alcohols contain the hydroxide ion. This is a statement that confused many students because OH is there, but we do know that OH is not there as an ion. These are not alkalis. Alcohols are not alkalis. Alkalis have hydroxide ions. Alcohols don't. Okay, so this is going to be wrong. Taha, I'll come back to 33 in a bit. Number 2, ethanol can be formed from ethene using a reaction catalyzed by yeast. This is again a difficult statement to comprehend because we do know that yeast helps make ethanol. And we also know that ethene helps make ethanol. But the problem is making ethanol happens through 2 processes. One is when you add steam to ethene. Second, when you use yeast in absence of oxygen with sugar. Okay, so there are 2 processes, fermentation and hydrolysis. So this one right now, not hydrogenation, hydrolysis. So this process is trying to combine, this statement is combining the 2. So this is wrong. Yeast happens on its own process. Ethene is used with water in its own process. Methanol can be oxidized to methanoic acid. That is true. We can make acids from alcohols through oxidation. So yep, this is true. In fact, we can use KMnO4, which is an oxidizing agent in our syllabus, to achieve this. Alcohols X and Y shown are isomers. Where are they shown? Let's see. Now, how do we know if something is an isomer? There are 2 cases in our syllabus where we know that these are isomers. Number 1, if they have different arrangement of carbon. So for that, what I usually suggest is that start at one end of the molecule and drag the pencil to the other end without picking it up. So you can see that I have connected 4 carbons without picking the pencil up. Now, if in the other one, I still have 4, but I can't connect them all, it might be an isomer. In this case, I can connect them 4. So based on this criteria, these are not isomers. So there are 2 criteria of checking isotopes in our syllabus. First one is this one. Second is look at where the functional group is. So from one end, this one is carbon number 1, this is carbon number 2. I can clearly see that OH is on carbon number 2. In this one, I'll start from the right side because we always start from the closest side to the functional group. This is carbon number 1. The functional group is carbon number 1. Clearly isotopes. So again, how do you identify isotopes? 2 criteria. Number 1, you drag the pencil and try to see if you can connect them all in the same fashion. If you can't, then it is likely that they are isomers. Number 2, look at where the function group is. In this case, these are at different position. So these are positional isomers. And yep, that makes them isomers. So this statement is again true. So yep, 3 and 4 is our answer. So D. Okay. Let me go back to question number 33. So This reaction is substitution. And in substitution, what you have to remember is that every atom is displaced one at a time. So in this case, chlorine is going to come in, get a hydrogen, form HCl. But because there's 4 hydrogen, 4 chlorine will be involved over time and 4 HCl will be made over time, because every hydrogen is going to be displaced and used to make HCl. Okay, so that is why we are getting 4 HCl overall, because we have 4 hydrogens. Does that answer your question, Taha? Great. All right, question 35. Amino acids are essential building blocks in the human body. Macromolecules in food are hydrolyzed to form amino acids. Okay, which macromolecule provides the body with amino acids? So amino acids are the building blocks of proteins. So yep, this is a pretty straightforward knowledge and understanding wala AO1, assessment objective 1, ratta basically. So this is option C. Carbohydrates, they are made from simple sugars. Fats are made from fatty acids and glycerol. So, yep, that's it. And D is not polymer. Sugars can be disaccharides or monosaccharides, but they're not polysaccharides. So, sugar is not a polymer on its own. Okay, 35 is done. Let's move on. Ethanol was reacted with propanonic acid. Okay, in the presence of concentrated sulfuric acid. Why are we using sulfuric acid? Because concentrated sulfuric acid is a dehydrating agent. So this will do elimination reaction and produce an ester. Which statement about organic product of this reaction is correct? Okay, so let's see. So they're going to react, they're going to remove water, just remove water, okay? So we are going to remove OH from one side and H from the other side. Let's say I remove OH from the ethanol, so I'm left with C2H5. And on the other side, I have C3H6. So I'm going to remove H, so H5O2. So there you go, C5H10O2, correct. Is it addition? No, this is esterification. Okay. So, yep, that's how we know. Why are we removing water? Because concentrated sulfuric acid is a dehydrating agent. That is something you have to remember. We use it to dry out different gases. We can only dry the gases that do not react with sulfuric acid. Can you think of a gas that we cannot dry using sulfuric acid?
Ammonia.
Ammonia, perfect. All alkaline gases will not be dried using sulfuric acid. Then we pass them over some basic drying agent like calcium oxide. Okay. How can alkenes be manufactured? So how do you make alkenes? There are 2 ways of producing alkenes. One is we take a large hydrocarbon, do cracking, and it will give us some alkene. One is that we take an alcohol, we dehydrate the alcohol, and then we get alkene back. So, yep, this one's going to be cracking. So D. All right, moving on. Which statement about alkanes is correct? Ethane reacts with chlorine in an addition reaction. Alkanes do not do addition because they don't have double bond. So this is wrong. Let me change it. There's one statement in here that I'll change. So what will I put in place of addition here?
Substitution.
Substitution, very good. Propane has a higher boiling point than butane. No, propane has a lower boiling point than butane. The molecule of alkane that contains 99 carbons has 200 hydrogen atoms. It's an alkane, right? So I can just use it. C99H 2 times 99, 198 plus 2, 200. Yep, sounds right. There are 3 isomers with formula C for H10. Let's try it out. 4 carbons, so I'll just put them in a row. 1, 2, 3, 4, done. So that's C for H10. Next, I will try to change some hydrogen with some carbon. That's how you make isomers, okay? So I have these hydrogens. I'm going to switch some carbon with some hydrogen. Okay, let me try this. Let's say I switch this hydrogen with this carbon. Why am I choosing that one? If I try to pick this one, I'll end up with the same compound. If I take this carbon and switch it here, it's the same compound again. If I do this one, it's the same thing. So it's hydrogen on the first carbon, the last carbon, if I switch them, doesn't help me out. Let's pick a hydrogen on the second carbon. Hydrogen on the second carbon and last carbon. Let's switch them. What do I get? Carbon, 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 3 carbons. And then the middle one gets a carbon. Okay, now I fit them with the hydrogens. Do I have an isomer? Let's see. I can connect 4, but I can only connect 3. So yeah, isomer. So this is isomer. Can I make any other? Let's see. What if I switched the carbon on the third hydrogen with this carbon? No, won't help because I'll end up with the same thing. So yeah, there's only 2 isomers possible. So this option is correct. In fact, butane is a pretty simple compound, and you should know that butane is the first one that we use to practice for isomers, and it only has 2 isomers. I know that some teachers do teach naming of these branched isomers, but in this year, it's not required. So you don't need to know the exact name of this isomer. You can just call it butane and isobutane, and that will be fine. They will not ask you for the name. Which statement about ethanoic acid is correct? Ethanoic acid can be made by catalyzed addition of steam to ethene. Wait a minute. If you're adding steam to ethene, you're going to get ethanol. You're not getting ethanoic acid. We will make ethanoic acid from ethanol. We can do that, but that's not happening here. Propanoic acid can react with ethanoic acid. 2 acids reacting together, who has ever heard of that? Like it does happen sometimes, but not over here. Solution of 1 mole per dm cube ethanoic acid and 1 mole per dm cube HCl will react with magnesium at equal rates. Wait a minute. We have the same molarity, but we don't have the same strength of acid. The reaction is going to be very different in terms of rate. HCl is going to be very fast because it ionizes fully. Ethanoic acid releases the H positive slowly over time because it's a weak acid. It doesn't ionize fully. So yeah, rate is not going to be the same. Can you think of something that will be the same? Like when they react together, what will be the same?
Sir, can you repeat the question?
My question is that ethanoic acid, same concentration, reacts with HCl. Reacts with what? Magnesium. And HCl also reacts with magnesium. What will be the same in both of these reactions? We know one will be slow, one will be fast, but what will be the same? Sabine is saying pH. pH will be the same if acid was if they completely neutralized it. If acid was completely used up, then the pH will be the same. What were you saying, Iman?
Sir, kuch nahi.
Okay. Concentration, we have said that it is the same. So that's up to us. So if we say it's the same, it's the same. Not really an insight. What else? Is there anything that will be the same? You see, both of these reactions will produce hydrogen gas. Right? So that's one product that is the same. And because we're using the same concentration and same volume, the amount of hydrogen produced will be the same. Sure, it will be slower with ethanoic acid. It will be much faster with HCl, but it will still be the same. Okay? All right, so that statement is wrong. And last one is formula of ethanoic acid is this. Yeah, that's true. It has 2 carbons. So yeah, D is the answer. Last answer for this one. Polymer Z has a structure form. Let's identify it. So first of all, it has carbon on both sides. So this is a man-made polymer, not a natural polymer. A natural polymer will switch. It will have carbon and nitrogen on either side. Then the linkage is amide linkage. So this is a polyamide. So let's see what is true. It's an addition polymer. No, it has a linkage. It is a condensation polymer. It is a polyamide. Yes. It's not a polyester because the linkage is not ester. So judging by that, it's 2 and 3. So the answer is C, and that brings us to the end of this paper. And I hope that this cleared many doubts for you. It was a good learning experience. I will be sharing a video with you. In fact, there's a video I made from grade 9 students that I think you should watch for today, because there are many small things in there that will really help you figure this out, because this is from grade 9. We usually forget about these things. So I'm going to give you one document that I need you to read every day. I'm going to give you the link to that video that I want you to watch for grade 9. I'll give you another video for grade 10 syllabus. And other than that, if you have any questions, feel free to ask. I'm here.